Greetings everyone, my name is Chu Qiao with metric number 193616, and today I'll be sharing about my final year project, which is on partial discharge localization in oil using fuzzy logic method. To begin, transformer oil is a highly refined mineral oil that operates in stable condition under high temperatures. Normally, the type of oil used is mineral oil. Insulation oil makes up the insulation system of a transformer, which will affect the performance of transformers. Over time, insulation system experiences insulation aging, which can lead to the failure of transformers. And one of the causes of insulation aging is partial discharge. Partial discharge is caused by the presence of gas bubble in the insulation system, which cause the formation of voids. And this can cause partial discharge to occur due to high local electric field. The effect of partial discharge accumulation is electrical arc and arc flash, which are very dangerous to humans. There are 4 ways to detect partial discharge, which are electrical, chemical, UHF, and acoustic method. The acoustic method is being used to detect PD because it can detect PD in real time, immune to noise, and it is affordable, and it is used in this project study. For acoustic emission, PD inside the insulation system of a transformer radiates part of released energy as a sound wave. To be able to pinpoint the location of PD in a transformer, multiple sensors are to be placed on the transformer, which is connected to a data acquisition system to be analyzed. By using various localization methods, the location of PD can then be determined. The problem statement of this project is that the quality of insulation system has a vital influence on the safety and economic operation of a power grid. The detection and assessment of PD condition is important to reflect the condition of the insulation system. The accuracy of detection and assessment of PD is extremely important. The objective of this study is to simulate the PD acoustic signals in oil, to evaluate various types of PD localization algorithm based on fuzzy logic method, and to examine and locate PD based on laboratory experimental and simulation works. There have been a few studies that are conducted by a few authors, and generally from their finding, they use TDOA, time difference of arrival, and also time of arrival TOA to locate PD source. Generally, if they find out that the errors of all sets of data is within 1 centimeter. The methodology begins with the preparation of this project study, then it moves on to PD simulation using MATLAB software. The experiment was also done using Picoscope as hardware and also MATLAB as software. Then the analysis was done to compare the results obtained from simulation and experiment, and the effectiveness of each algorithm is being compared. This is the test cells for the hardware. The picture on the right here shows the test cell, which acts as the insulation system of power transformer. This white blocks right here is the acoustic sensors, and altogether there are 3 acoustic sensors being used. Moving on to the PD localization algorithm, one of them is time of arrival. This is the equation of TOA used. Moving on to the next algorithm, it is TDOA, time difference of arrival. This is the equation that was used. Then, moving on to fuzzy logic. Fuzzy logic is modeled using TOA and TDOA data that was obtained previously. It takes in the AE sensors coordinates and time of arrival of sensors as inputs and outputs the coordinates of the PD source. Again, rules are also defined in order for the system to determine the output. In this study, Mandani and Shugeno fuzzy inference system were used to compute which system is better. To evaluate the performance of each model, the error between predicted PD location and actual PD location was calculated using formula shown. This is the result that I got from PD simulation. There are 4 signals right here. The black signal is the PD source, and the color signals are the sensor signals. The distance between the PD source and the sensors is TOA, and the distance between these sensors are TDOA. 60 data were collected for both experiment and simulation work where sensors were placed at different locations. This is used for TOA and TDOA localization algorithm. So this is the TOA coding. Here you input the sensor info and then the time of arrival of sensor. Then, using the equation of TOA right here, the PD source could be localized. Running the program. These are the results obtained from TOA localization. Moving on to TDOA coding. Again, sensor were inputs right here, and then time of arrival of sensors were also input here. Then the time difference between sensors are calculated using these equations. Then using these TDOA equations, the PD source could be localized. So this shows the coordinates of the PD source. With the data obtained from TOA and TDOA, some cleaning job is to be done to remove all the outliers which have no roots, negative values, or out of the bound of 10 because this will affect the accuracy. And these are the number of data left after cleaning. Then this data will then be used to be fed into the fuzzy logic model. This is the fuzzy logic model. Moving on to the fuzzy logic rule viewer. This is where the outputs of the PD coordinates can be seen, and you can see how the inputs are being used to output the PD coordinates. Here is where you put your inputs. Here you can see that the coordinates are being output and they are output in centimeter. From the results obtained from fuzzy logic, it shows that single set rules works well for experiment data, double set rule works well for simulation data. Mandelin fuzzy inference system generally performs better than Shugeno because Mandelin system has a more intuitive approach and is a more interpretable rule-based system. The overall result shows that the average error between predicted and actual PD sources are used to evaluate the performance of models. In general, simulation performs better than experiment data. TOA performs better than TDOA, and fuzzy logic improves overall performance of the PD localization algorithm because you can see that there is lower error using fuzzy logic method. The best model is fuzzy logic model using TOA method from simulation with only 1.08 cm error. In conclusion, fuzzy logic method has proven to improve PD localization performance in oil. The best model is fuzzy logic model using TOA method with only 1.08 cm error. For future researchers, they can consider all paths of acoustic emission propagation, use denoising techniques for signal extraction, use the bigger size of transformer tank, and collect more data for the modeling of fuzzy logic. That's all from me. Thank you.